Hi, and welcome back to Math Tales. I'm Cerene.
I'm Gideo.
I'm Shimon.
Today, I'm going to begin by telling you more about the structure of our series Math Tales. Math Tales comprises of 4 chapters. Chapter 1 deals with tales on the history of mathematics. Chapter 2 is going to focus on tales on the foundations of mathematics. Chapter 3 deals with tales on abstract mathematics. And finally, we wrap up our series with Chapter 4, which deals with applications of mathematics. Today's video features a tale that comes from the chapter on the foundations of mathematics. And this is going to be led by Gideo.
So in this video, we will specifically be considering set theory as a fundamental framework for all of mathematics.
Wait, so if we're talking about a fundamental framework for all of mathematics, what is mathematics?
Good question. So perhaps what we can do is we can think about what we had learned when we were in school. What were some of the areas? Well, we were introduced to arithmetic, algebra, geometry, and trigonometry. So the question is, what did these areas have in common? And well, what they had in common was abstraction. It was all about talking about these abstract entities. So I think perhaps our next step is to actually have an example about where did these abstract entities appear.
Okay, so for an example, let's consider maybe the simplest abstract concept we can think about, a number. And we're going to consider how we usually explain numbers when we're teaching very small children. The idea is usually if we want to explain something like numbers or why we want to add numbers, we give them a bunch of examples. An example like, okay, say we've got some pile of apples and another pile of apples. We count the quantity of apples in each pile, put them together, count the quantity of apples in the resulting pile. And we realize that this quantity doesn't deter or isn't dependent on the apples themselves. It could have been a quantity of anything. And as such, we can abstract quantity in order to just give us a different construction. In this construction, we term a number, maybe one of the first mathematical constructions.
That's very interesting. So if I understand correctly, abstraction is a very powerful method in which we can study several problems at once, several concrete problems, without worrying about the unnecessary bits of each problem.
Yes, Shimon. So basically, in mathematics, we are taking some property that we want to study and then disconnecting it from the examples that we were using. And since we are going to be studying a fundamental framework for all of mathematics, let's think about what exactly the property that we want to discuss is. And this is the property that objects, be they real or imaginary, constructed objects, consist of other objects. So real objects consist of matter, other abstract constructions consist of other information. And on a very primitive level, without thinking about how these objects are constructed, we can say anything is just a collection of the things that it consists of. And since we're going to be working with these collections a lot, we're going to be terming them sets. And we say one set X is an element of another set Y if it is in the collection associated with that set.
So how do we use sets to now build other mathematical objects?
Earlier, when you and Gideo spoke about what mathematics is, you spoke about studying abstract objects that have certain properties. Then it's very useful to consider, for any given property, the collection of all objects that satisfy that property.
So, Shimon, what you're saying is we can't just construct sets explicitly, but we may be able to consider sets where all of the objects in the set have a certain property. The issue is I can think of very many properties, and how are we certain that you can't have some weird property that contradicts itself?
Well, one can certainly run into issues, but that requires a deeper explanation, which we will save for another video.
Catch us at our next video where we speak about axiomatic set theory. We look forward to seeing you there. It's goodbye from Shimon, myself, as well as Gideo.